Good morning, children. We now know that current is the rate of flow of electric charges, and for the flow of charges, a cell has to keep on expending its chemical energy. That is, it needs to provide a potential difference. Now, to find out a relationship between current and the potential difference, this is an experimental setup as shown here. What is being done is there is a nichrome wire which has been taken, and there is a voltmeter connected across it, and this nichrome wire is connected in a basic circuit having an ammeter, a key, and an array of cells, wherein we will keep on increasing the number of cells as we perform the experiment. So as soon as we plug in the key, the current starts flowing, and basically if you look at it, we make an observation table based on this experimental setup. The observation table is like this. We will write the number of cells used, the value of the current, and the value of the potential difference as noted by the voltmeter and ammeter, and then we take a ratio of V upon I. Now what is being done is, to begin with the experiment, first one cell is connected. As soon as one cell is connected and we plug in the key, the current starts flowing. We note down from the ammeter the current flowing through the circuit, and from the voltmeter the potential difference, and find out the ratio of V upon I. Similarly, now we connect two cells into the circuit. That means this line will get connected here. So there will be two cells within the circuit being connected. So as you increase the number of cells, what you are basically increasing is the potential difference. Again, note down the voltmeter reading and the ammeter reading and complete the observation table. Like this, keep on increasing the number of cells and keep on noting down the voltmeter and the ammeter reading, and in the last row find out the value of V upon I. It is observed that once the values are received, it will be the same value for V upon I, which is obtained in each case. We will see that as the number of cells increases, the potential difference also will increase, and the current will also keep on increasing. The observation is that the ratio of V upon I will remain the same. Now if we plot a graph between V and I as shown here, we will get a straight line. A straight line implies that V by I is a constant ratio, and it's actually also implying that there is a direct proportionality between the potential difference and the current. Now according to George Simon Ohm, looking at these observations, he stated that the current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided the temperature remains constant. So if the physical condition, that is specifically the temperature of the conductor, is going to be constant, then there is a direct proportionality between the current and the potential difference. So as we in the experimental setup keep on increasing the number of cells, we will see that the potential difference increases and proportionally current also increases, and this statement is what is called as Ohm's law. So Ohm's law states that at constant temperature, the current flowing through a conductor is directly proportional to the potential difference applied across its ends. Mathematically, we can write V is proportional to I, proportionality being removed by equality, and the constant is put V is equal to IR. Here R is called as a resistance of the conductor, and it is the constant. So we can write R is equal to V upon I. The SI unit of resistance is ohm, which is shown by this symbol. So from this formula, R is equal to V upon I, we can write 1 ohm is equal to 1 volt upon 1 ampere. From this we can also write define 1 ohm. So we can say that 1 ohm is the resistance offered by a conductor across which 1 volt of potential difference is applied and through which 1 ampere of current flows. Now you can also see that to measure this resistance, or to provide this resistance in a circuit, there is a device which is called as resistor. So resistor is a device which offers resistance. What is precisely resistance? Resistance is the property of a conductor by virtue of which it opposes the flow of current. So resistance is a property and resistor is a device. So this is something that you keep on remembering that resistance is a property and resistor is a device. A device, a small component which when connected in a circuit will offer enough amount of resistance. There is something called as a variable resistance, and a variable resistance is a device which is used actually to regulate the current without changing the voltage source. Suppose you are connecting a battery and you don't want to change the source of that, you don't want to change the battery, then and still you want to change the current, then you can attach a variable resistance by which the current can be regulated. Thank you.